Given this permutation, let us try to come up with an expression of a product of transpositions that will actually result to the same permutation. Now take note that our transpositions should also be in the same set as 8 here, but we are going to have a transposition is actually a cycle of length 2. So we would like to see later on a product of cycles with length 2. This given permutation on a separate video were already identified as a cycle in itself, because this has, or this can be expressed in this manner: 1, 3, 4, 7, 8, 6, 5, and 2. This is a cycle because we only have one orbit, which in case resulted to this, that has that's actually more than one element. So we have this as our result in the previous video, and as you can see here, 1 is mapped to 3, 3 is mapped to 4, 4 is mapped to 7, 7 is mapped to 8, 8 is mapped to 6, 6 is mapped to 5, 5 is mapped to 2, and 2 is mapped to 1. So it actually fits the given permutation. Again, it's already identified as a cycle. Using this expression of the cycle representing the given permutation, let us try to come up with transpositions. Now we can write transposition in this manner. Since it's a very long cycle here, we have a cycle of length 8. We are expecting here what you call it, n minus 1. So we're expecting here 7 transpositions in this form. So we have here, of course, 7. You will have its transposition is a cycle of length 2. That's still 6, so let me remove this here, move this a little bit here, and that. So it's again a cycle of length 2. When you say cycle of length 2, 2 elements are being mapped to each other and the rest of the elements are mapped to itself. Okay, so this is how we do it. We copy the first element, 1, also 1 here, 1, 1, 1, 1, 1. And then we are going to pair this 1 with the rest of the elements from right to left. So we start with the farthest. So 1, 2. Then from right to left, we have 5, followed with 6, 8, 7, 4, and 3. Again, we started with the farthest, 2 here, then 5, then 6, 8, 7, 4, and 3. So this is actually the entire expression on the product of transpositions that will result to the given permutation. This should be the answer to this video. But of course, if you would like to verify that, you could always come up with your permutation: 1, 2, 3, 4, 5, 6, 7, and 8. And if this will result to the given, then that means our answer is correct. So let's start with 1. 1 is mapped to 3, but 3 is no longer here, so 3 is mapped to 3, 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 so just 1 is mapped to 3. Let's start with 2. Let's go with 2. 2 is mapped to 2, 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 2 is mapped to 1. 3. 3 is mapped to 1. You can see it here. Then 1 is mapped to 4. So again, 3 is mapped to 1, then 1 is mapped to 4. So we are now at 4. 4 is mapped to 4, 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 4 is mapped to 4. Let's have 4. 4 is mapped to 4 because there's no 4 here. But here, 4 is mapped to 1. Now we are now at 1. So 1 is mapped to 7. 7 is mapped to 7, 7 is mapped to 7, 7 is mapped to 7, 7 is mapped to 7. Next, 5. 5 is mapped to 5, 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 5 is mapped to 1. But then here, 1 is mapped to 2. So 5 is mapped to 2. Next, 6. 6 is mapped to 6, 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 6 is mapped to 1. Now we are at 1. 1 is mapped to 5, 5 is mapped to 5. 7. 7 is mapped to 7. 7 is mapped to 7. 7 is mapped to 1. Okay, sorry. 7 is mapped to 1. Now we at 1. 1 is mapped to 8. Now we are at 8. 8 is mapped to 8. 8 is mapped to 8. 8 is mapped to 8. Let's have the last 8. 8 is mapped to 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 1. We are now at 1. 1 is mapped to 6. We are at 6. 6 is mapped to 6. 6 is mapped to 6. So this is the permutation that will result to the 7 transpositions here that were actually taken from the given cycle. Is this the same as this here? The answer is yes. And that means this result here, the product of the transpositions 1, 2, 1, 5, 1, 6, 1, 8, 1, 7, 1, 4, and 1, 3 in the exact order is the expression for this given permutation as a product of transpositions. Thank you very much for watching.